thank you. Thanks, Amit, for the invitation. A pleasure to be here. What I thought I would do until that kicks me away is actually talk a little bit about, actually in three parts, if you will. I'm not going to spend time, come from the research lab, so my job is not to tell you about all the Watson APIs and what you can do with them. I'll give a brief flavor of that. I spend a couple of minutes on that just to set the context of what we have, but really spend time talking about what's cooking in the labs, if you will, the stuff that will start to show up in the platform over the next, whatever, 6, 10, 12, however fast we're able to make it. And then end a little bit with, coming from the labs, a little bit of sort of, future directions we are looking at. So that will be the three parts, and let's see how much I can get through. So at least from IBM's point of view, I know Dan mentioned Jeopardy. That was sort of just a sliver, an external view. IBM Research has been working in this broad collection of what we call AI technologies for, 80, 90 years. And what we see emerging, and I think Dan set it up beautifully already, so I'm not going to repeat his story. What we see emerging is a class of systems that you're going to see a partnership between humans and people. And we see really cognitive systems as enhancing, scaling, and accelerating human expertise. So whether it's in the education domain with tutoring, or it's with healthcare with nurses and doctors, or it's with compliance officers in banks, what we see emerging is a class of applications where human expertise and skill can be scaled, enhanced, and accelerated. And so that's sort of why we like to think of AI really right now as augmented intelligence. And that also helps because that gets away from this whole persona of strange species with arms and legs landing up to do various things. We want to sort of get away from that story, if you will. So that's our overall point of view on just the first message. The second, as a company that works with so many industries and Fortune 500 companies, we do see real examples of cognitive applications transforming every industry. And since we are talking AI, when I say cognitive, map it to AI, if you will, but we see truly examples transforming every industry, whether it is healthcare, whether it's financial services, sales, retail, travel, many. And the reason this becomes important is we believe that sort of the way we plan to bring AI to the world and to other ecosystems and innovation ecosystems is through industry platforms. We believe that until the vision comes in where there is some all-knowing entity we can create that learns along the way, you're going to get success by specializing your systems for industry domains. There is no getting away from the fact that if you want to build AI systems in the financial domain, you needed to understand a set of concepts. And you have to, whether you do it by training, annotating, labeling, the class of techniques used, you're not going to get away from that industry specialization. Same with healthcare. And I know, we talked about adaptation and so on. And until we get to the point where we can completely rely on those systems, we believe industry's focus is going to be a big part of what we do. So we think of our AI platform really in 4 pieces. And I'll very quickly get into what the labs are doing. So this is a little bit of a big picture view. There's the infrastructure, where we focus on all the things you would imagine. We would focus on acceleration, security, application development, how it comes in with IoT. As a full-fledged technology provider, cognitive to us is a big deal, but it also brings together all of the other technologies we can provide. So that's the infrastructure. Content is key, and that's where really a lot of industry specialization come in. So if you have noticed our IBM's push in healthcare, we've really heavily invested. And I think right now it's safe to say we probably have more healthcare data than most medical institutions right now across image, textual, radiology, electronic medical records. The reason is that you cannot make fundamental progress without first having data. Then comes the question of what class of techniques you're going to do, but that becomes key. So to us, content is key, and that's the industry platform focus. Third, even compute is obviously the way you deliver AI capabilities trained and built on the content out to the world. And I'll talk a little bit about the set of APIs we have available today on the platform and the new set of APIs that are going to come in. That's the compute. And all of these types of techniques and many more form the underlying engines, obviously, of delivering those capabilities. Finally, we're using the word conversation as sort of a metaphor, not necessarily conversation just being chatbots, but really as a way of delivering AI capabilities when actually they interact with external systems. Whether it is smart rooms, whether it is chatbots, whether it is interactive other experiences or actual real robots, that's the way in which AI capabilities interact with the real world. There again, we see that industry depth, understanding of business processes can add a lot of value in really taking these cognitive capabilities into something that is both useful and which people are willing to pay money for. So that's really our 4-part story, and I sort of highlighted the industry thing because we think that's fundamental to a successful strategy for cognitive. That's the big picture view of our approach. And so what I said, what I want to do is spend 5 minutes, just an overview for those who may not know about what the Watson platform APIs are, what's available, what's out there today. And then mostly spend time on the middle bullet, sort of a sneak peek into the areas that we are focusing on in the labs. We were a big team, so I can't cover everything we are doing, but I'll try to give a big picture of here are all the areas we're working on and a few examples that either my team or I personally am familiar with. And then I'll end a little bit with some future directions around creativity and where we see that going. So that's sort of the path that I'll try and chart. So APIs, this is the only marketing looking slide I have, so just bear with me for that. But just for those of you who may not know, what we have done is taken the collection of AI capabilities we have and presented as a set of services that we call the Watson Developer Cloud Services. Here are some statistics, I'm not going to go through with them. Here are SDKs available. This is the part that I think is best done offline, not in a presentation. But I just wanted to give you that message that it's available through our public developer cloud, the Bluemix platform. And we've seen a lot of adoption, many countries, numerous industries in numerous languages. And the way to think about this is the following. As we work with clients in individual industries and build capabilities, to the extent we are able to abstract them away and deliver as APIs, those APIs start to show up on Watson Developer Cloud. What we have seen so far, and here is just a summary of the type of APIs that are available, right? Again, I'm not going to go through the list, but you see this covers all of the basic stuff you would expect, a whole collection of natural language processing capabilities, speech, text, image, visual, and then of course more advanced capabilities. Start to see elements of reasoning and comparison, things like trade-off analytics. That's a set of services that are available. And I will go through one example where a startup, an external partner of ours, has actually built a solution using 6 or 7 of these APIs. So that's the way we see the world moving, where people innovate on top of our platform. Where I want to go when I talk about what we're doing in the labs is, how do we then start to bring industry context? If you're a startup developer or a company, you can do a bunch of things today with these APIs. But what can we empower you with more if you're working, let's say, in the fintech space, or the edutech space, or the health tech space, or some other space? How do we infuse industry domain expertise baked into the platform so that then you're able to accelerate your innovation further? That's been really the focus of what we do in the labs. So before I get there, give one example of a system that's been built. So this is actually a demonstration from a partner of ours called Talview. So they are a HR, human resources and talent management company. They have a suite of products. One of their products is something called Talent Insights. And this may not be an exhaustive, but at least a set of the capabilities they use from the Watson platform to provide talent insights. So use case here is essentially talent management and recruiting, something we are all aware of. And I'm going to sort of play a video that talks about what they do. So we start off with your typical job requisition. So there are a set of applications for a job. And the first pause here is, in the background, the job description, details, requirements are all in textual semi-structured form. All the applicant information, including both their profile, the bio, the CV, if they have recorded conversations, everything is also available. And so the system has processed in the background and built up an understanding of both the job requirements as well as the applicants. There are a set of applicants that are possibly explicitly added to this requisition by human beings, but the system does make suggestions at the bottom about possible applicants by matching. So the actual matching is proprietary to Talview, but the matching builds on top of the understanding of unstructured data that's been provided by the Watson APIs. So then we keep moving forward. The particular one of the recommendations is chosen by the system, added to the collection of applicants, and now you're trying to compare applicants. So the system goes in, you can select a few applicants to go dig deeper into them. They have been added to the assessment. And then you start diving and looking at the details. So this sort of gives you an example of the type of text that the system has processed. This has been turned into specific requirements and job role. And at this point of time, what happens here, I want to pause, is that certain activities are recommended by the system. So there is a gap analysis made to say, look, the person's CV demonstrates these capabilities. There are a few other things we are not quite sure about. So of course, then you decide whether you're going to do a code test, a live test, an interview, and so on. So let's say for this applicant, he's invited to an interview, there's a programming context. Now, all of the data generated through that interaction are also processed using Watson APIs. This includes both video, speech, and the textual interactions. These are analyzed, and by the way, the last thing that's also done is personality analysis. So that also emotion, tone, and personality analysis is also included. And then at the result of all this, the system goes back and now to the recruiter presents a view of the applicants and their match to the job requisition. Now this obviously is a trade-off. We all know hiring is a trade-off. So again, this underlying service that's used here is a service in Watson called trade-off analytics that lets you, without understanding the math behind various decision-making procedures, allows you to say, here are the dimensions that I care about for this job requisition, position the candidates for me in terms of their suitability. And so now you can dig in to the most recommended candidate and move forward. So, I'll stop this video at this point, but the message here was a collection of capabilities. A lot of hard problems were solved by the platform so that the application developer here focused purely not on the NLP, not on the speech, not on the text recognition, not on the emotion analysis, but on building the specific capabilities required for this domain, which is customizing the NLP for the HR domain, of course, building the actual application. So I think that's the power of the productivity and to some extent the democratization that Dan was talking about that puts the power of all of this in the hands of people to build interesting applications. And as I said, there are many that are being built by IBM, our partners, and developers all over the world. So just a little illustration of the platform. So I'm going to quickly move in to talk about what we are actually doing in the labs. So here is a big picture. So IBM Research and our development labs, thousands of people across the world, and we sort of view our AI agenda in 4 big buckets, if you will. The first bucket is what we call signal comprehension, which is whether the signal is an image, text, video, or audio, you got to understand it, right? So all of the natural text understanding, visual comprehension, speech and audio processing, that continues to remain. And as was illustrated in the previous talk, while we have come a long way, there are many more challenges to continue to solve. So that's definitely one domain. But once you have started to get signals, once you understand the raw data a little bit better than as raw data, what do you need to do? You need to get into specific domains, whether it's HR, finance, and so on. So the next set of technologies we are working on is really around what we call reasoning about domains, which includes basic things like knowledge representation. How do you represent data in a way that you can do reasoning and planning, learning, and decision support. So that's a second cluster of technologies that we work on. And I will give you examples again of how very deep natural text understanding coupled with domain-specific reasoning and start to really address some interesting problems. So that's the second category. The third category, all said and then you can't get away from people. I already mentioned we have APIs in the platform that do analysis of people's text and audio and video to attach both emotion, personality, behaviors, profiles to them. Obviously, that's just a starting. That whole space of interaction between people and the broader area of smart rooms and embodied cognition, that's a third sliver of work that we do. And the way to think about this is what's in the Watson platform today are bits and pieces of this that are ready for mainstream that are put out, but then many more from these will start to make their way into the platform as the technology matures. The last bit of work we do is obviously the underlying infrastructure, which is what does it mean to do software development? Today, development of cognitive applications is actually very different from traditional software development in the sense that you have to think about code and data together. You have to think about training cycles. You have to think about model management. So what are the set of capabilities that we can give to developers so that that entire space of development of cognitive applications is accelerated and simplified? So that's an area of focus. And finally, of course, the underlying platform, whether it is hardware acceleration, scale, security, that's a fourth area. So clearly in the time available, I don't have the opportunity to go through all of them, but I felt that this big picture would help as you will start to see connections between these areas of development and research and how they show up in the Watson platform. So I'm going to focus really on the first couple of pillars, if you will, to give very specific examples. So the first use case, compliance. I'm using this to illustrate a real business problem which requires massive natural language understanding and reasoning. At least in the mature world, compliance is a triple-digit billion-dollar problem. And it's a billion-dollar problem because ever since financial crises 1 or 2 or however you want, there have been a surfeit of regulations that make the task of financial entities harder and harder to actually adhere to everything that regulators all over the world want to see. And it's only getting harder, and it is really complicated if you're a company spread all over the world with many, many countries. So as one data point, depending on how you count it, it's $270 billion to $450 billion of money is spent just dealing with compliance, which means you don't make money of it. Just sticking to the regulations, you spend that kind of money. And why is this a hard problem? It's a hard problem because regulations are very sophisticated documents. So one of the areas that we are working on is the ability to very deeply understand regulations, whether they are healthcare, environmental, financial, housing development, rural, using deep natural language processing capabilities, and to basically, to the extent possible, automate the entire process of doing compliance. So what are the example problems that we have to solve? We have to be able to take text like this and turn it into what we call obligations. So regulations are all about you must do this, you must not do that. Your partner must do this, your partner must not do that. If you do this, then you got to do that. And can we turn very complicated, sophisticated legalese, if you will, turn it into concrete obligations that I can work with. Because now I can go back to my internal business processes and say, hey, this is what I'm supposed to do. Am I doing it or am I not doing it? If I'm not doing it, I'm in trouble because I'm not adhering to regulations. Now you might ask, why is this important to me if not working in compliance software? The way to think about it is, while we develop and address this market of compliance using cognitive technologies, the technologies we are building to go do this are going to be generalized and made available. So deeper natural language processing capabilities, and while we may do it for this, you could use it to maybe address tax fraud in India. So the underlying capabilities will be available on the API, the use cases may differ, but what we are doing is really pushing the technology of what's possible to do. After you turn things into obligations, an even harder problem is to be able to match obligations to internal controls. Today you have a business process that says, I'm going to include business security requirements in access classification scheme. Now the question somebody is going to ask is, does this take care of that obligation that regulation told me, or am I not taking care of it? So that mapping becomes very important. And it is even more challenging because regulations continue to change, evolve. If anything, they are increasing. So as a human being in a company, you will be just employing people to just keep track of regulations and make sure your processes are in hand. If a system can do that obligation extraction and to some extent also do the matching for you, what you start off with is an exposure, an analysis of where you are likely to have gaps that you can focus on. You may not be perfect, but at least you have taken away a lot of the manual labor involved in dealing with these really, really complex documents. So that's one example of how we are taking a real enterprise use case, building deep technology to address that use case, and what you will start seeing is then enhanced capabilities for various types of natural language processing starts show up on the Watson platform as a consequence of this development. Another example is, we talked about simple questions, we're answering simple questions. This is a very sophisticated question. It's still a question, but it's not a question you can type into Google. You cannot type into an average search engine to give you an answer, because it requires you to truly understand the domain and reason about it. This is saying these are certain FAQs and Q&As from a certain organization. This is a whole bunch of rules and supplements, and sometimes the supplements go off and point to other documents. Using all this information, can you ask the question whether a modular home is a manufactured home for the purposes of a certain regulation? It's a complicated question. Today, human beings spend hours, paid a lot of money to be able to do this, and to the extent that the systems can even reduce their time, let alone actually answer the question, tremendous possibilities exist. So these are examples of the type of problems we are attacking in the labs, and that's one. The next level is to start getting into not just natural language understanding, but be able to start doing reasoning in the real world, the type that you and I do. Given the client record, and this is in the insurance scenario, and a set of policy and product documents, can you actually answer client questions custom to the client? Complete taking into account all the specific situations. Now, we've been working in the insurance industry for a long time. A lot of our clients use IBM platform to build chatbots and conversation service to address basic questions. What do I do? Where do I fill my premium? Is this covered? You can get somewhat with those types of capabilities, but this requires much deeper understanding. To be able to actually calculate that person's premium, given all their choices and the policies, is a very complex task. Their location, age, gender, the options they have chosen. So very complex task that eventually you're trying to figure out whether you can get a system to do on its own. Now you might ask, is there value in the system doing it on its own? Again, we always come at it from, if we are able to solve this problem, there'll be a whole bunch of additional hard problems we'll solve along the way that we can deliver as capabilities into the platform, and that's really the output that we are looking at. So just some examples of where we are pushing natural language text understanding in the labs. Different domain, visual understanding. So what you see out on the platform today is horizontal technology, general purpose object recognition, the basic things that you would expect to see if you said I have a set of image APIs. Where we are going is specialization, to really look at particular industries and get really, really smart at image analysis for the domain. Talked about healthcare already. We have teams looking at probably the largest collection of radiological images to figure out how much we can do with radiological images. Can we understand them? Look at tumor scans. Can we make do with poor resolution data, or really always have to invest in the type of data that you have to go to full-fledged clinics to do? Health is one example. We're looking at safety, real estate, retail. I'll give you an example of what work we are doing actually in fashion and retail right here in India, which is of that flavor, which is specializing image technology for that domain. So that instead of understanding the images, okay, there's some person here walking in a green field, be very specific about what they are wearing, down to color, texture, style, and so on. So that's the specialization of the visual world that we are working on. So two examples from the signal comprehension bucket. One large theme we have, which I will illustrate with a demonstration, is we have recognized that when we work in actual customer engagements, we do this quite a bit. Before we can employ the APIs to build applications, much of what we do is this data curation. Now, today, the APIs we have in the platform to do data curation are very, very minimal, but we believe that that's going to be a big deal breaker. It's not just sufficient to offer interesting natural language or image processing services or raw machine learning services. We need the ability to offer APIs where developers can come in with their content, or industry experts can come in with their content, be able to turn raw content into knowledge graphs on which you can do reasoning and higher order processing. And this is a very painful and laborious task today. So what we are working on is abilities to then surface it and make the task simpler. So what I'm going to show you is an example of work we did in the financial domain. And I won't run through the video, I'll sort of step through the video. So what you're seeing here is a small sliver of what we call a financial knowledge graph. This knowledge graph, this is an ontology, not instance, right? This is just a structure and shape of the ontology. So there's about 350 entities, about 100,000 attributes, and of the order of close to 2,000 relationships. And this ontology is, so I'm just going to focus into the level of modeling we are trying to do. So we'll see, you will see that this ontology has powerful relationships. It has inheritance, it has bilinear relationships. So here is an example of how lenders and loan agreements are modeled. The ontology is agnostic to where the raw data come from. So the ontology models company sentiment. You could get it either from structured data or from processing analyst reports. So it's a view of the financial world. Let's say, and it has applications for risk modeling, let me actually stop this here. It has a whole bunch of applications for investment analysis, portfolio analysis, risk modeling, and so on. And what we have is a system we have built which takes, there are more data sources, unfortunately I cannot include here. These are all, some are publicly available, some are our partners. So SEC and FDIC filing, every public company in the US files, beyond a certain government files filings. They file many, many filings during the day. If you are in the financial industry, you additionally file with the FDIC. Crunchbase, you all know what Crunchbase has. And then Morningstar gives you in both reports about specific industries and companies. So we have a system that can continuously ingest this data and create a knowledge graph. And currently we have that many facts, company, and person objects now. What is this used for? There are many, many uses for these. We have partners working using this knowledge graph, as I said, for risk analysis, portfolio analysis, and so on. Because today, the information in these documents is very hard to get out. What an S&P or a Bloomberg or any of these financial data providers do is give you a sliver of that data, which is what you build models on. But there's a lot more sitting in those filings that is never understood. And if you have seen ever one of these filings, that's typically an 80-page PDF or HTML document. Really complicated, lots of tables, lots of text. But once you are able to turn it into the knowledge graph, there are many applications you can build. One example of an application we are working on is to give you the ability to do this. So I have now turned it into structured data. I'm not going to explain how we do this. Can I answer a question like that? Show me restricted stock investments in Alibaba since 2012 by investor and year. And the answer is yes, we can give you an exact precise answer, at least to the extent of what's out there in the underlying document, by actually turning this in a very principled way into a structured query that can run over the ontology. I'm not going to tell you how, but I'm just going to give you a few examples of what we do. Now, this is beyond the technology that is out there in our APIs, but this is the type of stuff we are building that you will be able to leverage shortly. So just let's listen to the examples. These are all eventually being answered over unstructured data, but after curation. So evolution of Wells Fargo loans. So think of this as an interactive exploration, somebody looking at Wells Fargo. Who are key borrowers of Wells Fargo? By the way, just this question alone is a very complicated question to answer, because the information spread across hundreds of filings. So you look at Hess Corporation. So what does the market sentiment look like? So Wells Fargo, one of its biggest person they have lent to is Hess Corporation. So I want to understand how Hess is doing. Hess seems to have a fairly negative market sentiment. The street doesn't think Hess is going to do very well. Well, why is that? Let's look at all the details. So let me pause here to make a few comments. The set of explorations you saw would have taken an analyst probably 10 plus days to actually do it right. Research, pull in a lot of information. But with the ability to now interact conversationally, the analyst is asking a set of questions about Wells Fargo, their lending, the health of the company that Wells Fargo is lent to, completely interactively. And he is being able to access the original authentic data that comes from sources like the company filings. So that's an example of the type of applications we are building. And this does not stop here. We have applied the same technology of building huge knowledge graphs automatically using a large number of NLP techniques, but then providing conversation and interactive precise questions that are answered perfectly. Not answered with passages of text, but answered with real answers, charts, graphs, and analysis. This is in the customer sentiment domain. Looking at use cases where customer sentiment about TV shows is being analyzed. This was based on a huge knowledge graph built out of social media analysis. Here is another example in the weather domain. Look at the complexity of the question. You cannot get this question today anywhere. What is the weather forecast for tomorrow at Delta's hubs? So the only way you're going to answer a question like this is to be able to build a knowledge graph for that type of domain and understand the semantics of this domain. And you can then provide precise answers exactly of the type that that application will want. So that's one example. And the key message there is you are moving away from the world of trying to give some passages, trying to give some snippets of text and get the reader to read it and think he has the answer, into more and more pushing the boundary on the completeness or robustness of the answer that the system gives back to you. So that's really where we are trying to get into. And that requires both the back-end processing on the raw documents as well as the smarts at the runtime to understand user questions, to understand the types of questions that were getting typed in, turn it into precise queries that give you back the type of answers that we saw. So that's one flavor of the technology that we are building. But let's kick it up a notch. Everything I showed you, I independently said we are working in images, we are working in visual, we are working in text. Can we give that kind of experience in a multimodal fashion? So can I build systems where in a very seamless way, the user can move between the textual and the image domain and not even know he's moving between these two and have a conversation and interact with the system. So that's what inspired us to get into the fashion domain. And so let me first begin with a little video and then I'll talk.
How do you turn cold code into warm fabrics?
used a number of Watson APIs to analyze more than 10 years worth of fashion data. It also included images, social conversations, so we could really look at what was trending and what people were interested in.
It's allowed us to work with things we had not considered in the past. It's allowed us to look at the collection, a little bit differently. It's allowed us to have more time to do what's relevant. So this has been easy because it's been really streamlined and a lot more directional.
So there were actually two things happening here. And I'll talk about the underlying system is essentially a multimodal conversational system for fashion, and if you will, that entire world of apparel and fashion. And there were two use cases roughly that got sort of mixed into the message. If you notice carefully in the middle, there was examples of an interactive system which really understood fashion queries and knew, understand, interpret sardis, the leisure, knew that you were asking for a certain gender, it knew what a v-neck was. So that's that entire piece, that domain-specific understanding system that you could put in front of end consumers. The other was the same underlying system exposed to the designers. So the person you saw on the screen at the end is actually a fashion designer. And this work was done as part of the Melbourne Spring Fashion Week, where that designer's collection for that Melbourne Spring Fashion Week was actually created by him working with a Watson system that used last 10 years worth of the top releases along with social conversations. The same underlying technology, but now targeted not at end consumers, but targeted at designers. So the question that the designers asks are very different from what the consumer asks. He asks very detailed question on color palette, style, and structure. The designer even used to get inspiration from architectural pieces, would take a photo of a building and throw it at the system and say, show me dresses that have the same broad pattern of the structure of that. And so, but the same underlying system actually served both of these use cases. And we are starting to see a lot of interest, in fact, even in the design community, not just the end consumer company, to be able to work in something like this. So if I dig a little bit deeper into what we did, this was sort of the vision that we start with. Now, this is a storyline that I'm going to spend 2 minutes on because it gives you the individual capabilities we are building that come together as a story. So this is the experience of somebody trying to shop for a party dress. And I'm just going to let you read the conversation, but it illustrates a set of 3 or 4 capabilities. One, somewhere in there, starts with a textual conversation, you move into the image domain. So at that point of time, the system moves into you start looking at some images that you like, then you move into the image domain where you're then just doing, okay, show me more like this, similar dresses, similar styles. That's completely the image domain. You can come back into the textual domain, start continuing the conversation. So that's that multimodality. And it's doable because we have an underlying ontology which doesn't care whether the information comes from text or images, as a uniform representation that the system can use to work with. Second, there is this trending, so which is where a lot of social conversation and deep analysis of fashion blogs, including fashion expert information, is being used to predict and do trends. So you can even ask questions about that trends. That's a second capability. And then the last one is suggestions, which of course every marketer wants to do. You buy the top, I want you to sell the bottom, you sell the bottom, you buy the bottom, I want you to sell you the top. That's another one. And again, this is driven by things that the system has learned from recommendations and blogs across the universe. Now, the way we are surfacing this is actually as a collection of APIs. So for those who are interested and are working in this domain, very soon we'll have a few APIs ready for experimentation, which will have individual slices of these capabilities that you can use in your own applications. So and this is just a story that puts together how you might use those APIs. Another example, we've done it in the jewelry domain. Very similar, but again, the key is multimodal, conversational, highly domain aware. Those are the 3 fundamental principles through which we're building systems like this. And I'm happy to show detailed demos offline for each one of these use cases. And what is the underlying system? The underlying system essentially is built on a huge fashion taxonomy, populated both by internal private data if you're working with a particular customer and their product catalog, but a whole bunch of external data, both fashion images, text, blogs, conversations, everything, collated into a single knowledge graph for the domain and then surfaced as a collection of capabilities. Visual search, natural language search, domain-specific search, suggestion, trends, that entire gambit of capabilities. And again, the reason we are doing this is also because as part of building this, all of the underlying technology APIs are being made available to you. So that's one example. And I will not have the time to go into these other pillars because I want to talk a little bit about sort of computational creativity. You already saw where we were going with fashion, which is not stop at only applications that target end consumers, but talk at applications that cater to the creative people or the designers. But obviously, we want to push the boundary a little bit more. Just briefly touching upon some of our focus areas here. One of our big focus areas here is around people insights. We are already on the journey with understanding, as I said, personality, emotion, and tone, but I think we're just barely scratching the surface. There's a lot of interesting work happening in the labs around how much can we bridge the gap between the system's understanding of a person's behavior and preference versus the amount of data we need to get to the point where we get there, because the challenge is always the data. And to the point that the system can continue to make reasonable progress with smaller and smaller amounts of data and again be multimodal. Maybe I can figure out the personality of the domain, not just in the textual domain, but if there is a recorded video, I have cues, which is what human beings do. You judge a person by body language, by their facial expressions, the words they use, the pace of their conversation, all of those things. And can we start to get to that level of understanding? That's one of the many interesting focus areas here. On this one, on the last one, again, one of our, as with many other of our competitors as well, a large focus is around acceleration of deep learning. Since so much of the work here depends on deep learning as an enabling capability, a lot of our work here in the infrastructure side is deep acceleration of deep learning. Other important and interesting dimension is also energy efficiency. And so some of you might have heard of our work around brain-inspired computing, where we have custom purpose chips for video recognition, which have energy consumption that are 100,000, order of magnitude smaller than a full bowl system. And so what we are trying to do is, can we push the infrastructure to be smarter and smarter so that the cost of the APIs and the services become cheaper? So just two examples of research areas that we are working on. But what I was emphasizing was this piece because that's much closer, and many more of these capabilities will start to show up on our platform sooner rather than later. Some are already available, and I'll be happy to chat with you. So the last piece, so future directions, and I think I already hinted in some respects. One of the areas we are looking at, and by the way, at this point, I am sort of backing away from, I'm not going to make any statements of where any of this will ever show up on the Watson platform, so this is really looking ahead. But one of our definite interests is in computational creativity. Right, so yes, you can assist human beings, you can enhance human beings, maybe do it faster. Can you really either assist creativity or be creative itself? And by the way, this is a very philosophical statement, so we are happy to have that conversation over lunch. But this has always been something we have been thinking about. We did something called cognitive dress, which is a different incarnation of the work we are doing now in fashion. We've always been looking at chefs, can things learn how to put interesting recipes together? And some of you might have known the work we did with Morgan. I'm going to run the trailer right now. But broadly, we are saying, look, we are doing this, read, see, hear, we're already doing that. That's the signal comprehension domain. Our focus so far on deduction reasoning has all been towards, okay, what is the application? Can I solve compliance? Can I solve healthcare and so on? But what about all these other things that human beings do really, really well, which really leads to creativity? And I don't claim to believe that any APIs will show up for this anytime soon, but nevertheless, we are working in the labs on these types of capabilities. So, designing recipes, we're taking a crack at it. Creating a movie trailer, I'm going to show you what work we did. And I'm just going to leave you with that just as a way of inspiring your thought. So let's just look at the movie trailer. So this was work done with Fox, who approached IBM Watson to create the trailer for a movie called Morgan, which was I think it's a science fiction slasher movie, if I'm not mistaken. Sorry.
Fox approached IBM and they said, well, we have this movie coming out. It's called Morgan. And it's an AI horror thriller. And then what Fox asked was, could Watson analyze the movie and generate a trailer automatically?
As human beings, we're very quick to judge the mood of an individual. Possibly an AI over time might be able to develop those same instincts.
So we thought, let's send Watson to film school.
Morgan was our little breakthrough. It exceeded our wildest expectations. Here you have the whole of the Morgan movie, and you can see where action is taking place at the different moment of the movie. And this is how Watson actually extracted salient moments from Morgan, which we then proposed for making the trailer.
Watson was able to model the scenes visually to determine, was a scene scary? Was it a tender moment? Was there sadness or happiness?
Watson is the tool that's helping arrange the visuals, but it still needs the human element. So then I can come in and just supervise the creative aspect of it.
I don't think AI has any value until it does start to understand and calibrate those emotions for itself.
I think that's asking a deeper question. Will computers be able to create art? Can they create? Period. It's still very difficult to think of how a computer might be capable of original thought, something that's essential in creativity.
So just to give you a flavor of what was done, and so just to make be clear, honest, what was done, the eventual trailer was put together by a human being. But like with the fashion designer, what the trailer creator had in his or her hands was the ability to navigate his entire movie along all the dimensions that he or she would be thinking about creating a trailer. And in fact, you could even create different kinds of trailers, if you will, from the same collection. So what were the basic underlying capabilities? One was shot boundary detection. What is the way in which you meaningfully chop up the film? Because sometimes the chop is visual. You really move from one room into the outdoors. Sometimes the chop is a human being enters and the conversation changes. So you have to use all three modalities to actually figure out how to segment. Second was audio segmentation. And then this was sentiments. And again, the sentiment, and I think John was saying, to classify a scene as either tender, scary, emotional, whatever it is, you're going to have to use all three modalities, because the filmmaker at that point of time might have using any one of these three modalities to convey that emotion. Can you build systems that can track that? And then of course we did basic things like, if the trailer creator wanted to make sure that this character showed up enough in the trailer, of course he would be able to only look at those screens where that particular character appeared. But essentially you got a palette, a tool to create a trailer, custom trailer. So that's an example of, I think, where we really wanted to push this. Last example, we are working in the lab in this whole area of computational argumentation. And by the way, this has lots of real use cases too. The question is, we talked about the system, and I'm putting it under creativity, but a lot of times argumentation is also creativity. We put it in that bucket, but let me tell you the example. The computer today, we are trying to get it to answer better and better questions, from simple questions to complex questions to questions that involve reasoning to questions that involve understanding the domain. But can the computer also allow pro-con analysis? Can you give it a position and ask it to look at that statements that are for that position and the statements that counter that position? Now, why is this useful? This is useful because you're going to have many situations where the human being is the eventual decision maker, whether it's the movie trailer or the nurse or the doctor or the radiologist or the financial advisor. So now today we are in the position of trying to help that person scale and do better. But can we also help the person be his sort of conscience? So if the person says, okay, I have decided I'm going to take this medical procedure. Now system, tell me what are the pros and cons. And that is a useful thing. This is no different from the doctor going and consulting his or her favorite friend before making a decision on a procedure, right? Can we have the system help that? That's sort of the vision behind this. Clearly, this is still in the labs. So everything you saw in the last 3 minutes is still in the labs, but I just wanted to end with that type of a flavor. Thank you again, and I hope to chat with you offline.